Today we are going to cover lesson 8.6. It is going to be solving quadratic equations by factoring. So on Friday I gave you a review and we just went over the answers. So the warm-up is exactly what we did in the homework. Numbers 1, 2, and 3 are just FOIL, and that's how you would always check your factored answers. Is FOIL it, make sure it goes back to the original. Then on questions 4, 5, 6, and 7, this is what we did in the homework over the weekend. So let's go ahead and see how we're going to use this. We're going to be solving quadratic equations by factoring. We've already solved quadratic equations by graphing. And when we were looking for solving the quadratic equations by graphing, we were looking to see where did our graph hit the x-axis. What we're going to be using today is called the zero product property. So basically what we're going to do is set each one of our binomials equal to 0 and solve for x. So here is just, they've already, let's say they gave us a problem to factor, and they came up with our two binomials. Notice how I just demonstrated when I was going over the homework. You take each binomial, set them equal to 0, and solve for x. So we're actually, okay, so you set each one equal to 0. We're going back to what we learned back in chapter 1 by solving these simple equations. And we use inverse operations where if it's a subtraction, we're going to add. If we're adding, we subtract to solve. So our two solutions would be 7 and -2. What these solutions mean is where our graph will cross the x-axis. So here, they're telling you to check it out. You would plug in 0 and solve and see if it works. Here's another example of using the zero product property. Again, you take each answer you've gotten, so the x minus 2 and the x, make two equations. You're going to solve each one. This x right here, the blue, all you do is put x equals 0, and that's your answer. Then the other one, the x minus 2, you would have to work for that one. You would add the 2, and your solutions are 0 and 2. Yes? All right. So here, you can substitute each solution into x to do a check. Here's another example. Again, they've already done the factoring for us. Most of the questions on your test, I'm going to make you factor it. I believe I'm giving you one where it's already factored for you, and you're just going to set each piece equal to 0 and solve. And then you get your two solutions. So once you subtract the 4, your solutions are 0 and -4. Okay, here's another example. They've already factored it. You take this binomial, make it equal 0. To solve it, you're subtracting the 4 from both sides, and you get x equals -4. On the red one, you're going to set that equal to 0. You would add the 3, and you get x equals 3. And this is where our graph hits the x-axis. Okay, so this is what you're going to be given, is I'm going to give you an equation. Make sure it's in standard form first. So make sure it's ax squared plus bx plus c. You're going to factor it first, and then you set each one of your binomials equal to 0. Let's try one. So here it's telling you to review your factoring techniques. We did that on Friday. If again you're still struggling, go back, and actually, this was, I believe, 7, not 8. So go back and review chapter 7 videos if you're still confused about factoring. So here's our first problem. Let's go ahead and try it out. X squared minus 6x plus 8 equals 0. I am looking for two numbers that multiply to give me 8, but who will add to give me the middle, which is negative 6. Notice because my last number is positive, my signs need to be the same. So my two numbers are going to be negative 2 and negative 4. And when I add those, I also get negative 6. So here, set them up. X minus 2, x minus 4. Set now each one equal to 0. So I need to make two problems here. And then I solve for x. I will add 2. My first solution is positive 2. And my second solution is positive 4. Make sense? So now that you reviewed the factoring, this lesson shouldn't be that difficult. Okay, here's another one. Notice this one is not in standard form. We need to make it equal 0 and put the 21 over on the other side. So I have x squared plus 4x equals 21. I need to move the 21 to the other side. And now I can begin my process. I'm looking for two numbers that multiply to give me negative 21, but add to give me positive 4. And those are going to be plus 7 and minus 3. Because 7 times negative 3 gives me negative 21, but 7 plus negative 3 gives me 4. So now I set each one of my binomials equal to 0, and I solve. This one gives me a 3. This one gives me negative 7. Should catch up in a minute. There we go. And those are your two solutions. So when it says to solve by factoring, you are going to factor it and set each binomial equal to 0. When you take Algebra 2, the instructions might be different. They may say find the zeros. And again, the process is still the same. Or in Algebra 2, they might also say find the roots. And this process is identical. So this is why you're going to need to make study guides to understand what all the instructions mean. Like it is here, or you could write what they put it here. Sometimes they're going to make you write it in set notation. So you could either write out the solutions are negative 7 and 3. Don't put them in parentheses together because that looks like an ordered pair. So if you're going to write it together with a comma in between, put it in set brackets, okay, or just show this. And when we review for the test, I'll tell you how you're going to see it on the test. Let's look at another example. So now, here's our same question that we just saw, and they just want you to show that you could also graph it to confirm that those two numbers we just found, the negative 7 and the positive 3, to see if it does really hit the x-axis at negative 7 and positive 3. And it does. So again, the solutions we're finding is where our graph will cross the x-axis. This is something you can do on the test if you wanted to confirm that what you did was correct. Here's another example. This is actually a perfect square trinomial. However, you can still do it the same way. Two numbers that multiply to give me the 36, but who will add to give me negative 12. And those two factors happen to be negative 6 times negative 6, and also negative 6 plus negative 6 gives me the 12. Yes?
I think you can square root it.
You could square root the 36, but not the 12. The 12 isn't a perfect square. Okay, now notice on this one, it only has one answer. Okay, so it can have one solution. Because remember, we saw in our graph, this one would be sitting right here on the 6. That's why it only has one solution. The other ones that we've seen previously, remember your graph is hitting it twice. The other ones are going to be irrational where there's no zeros, but you're not going to have anything like that on your test, but you will in Algebra 2. Okay, here is the graph of that one. All right, so when it only had one solution, notice that it's only hitting the x-axis one time. And that's okay, it could have 1, 0. Okay, here's another one. You need to put it in standard form first, and then from there factor. Notice this one was a little bit more complicated. They had to factor out a greatest common factor first. Now, we did this in chapter 7, so let me work through this one because this one's a little bit more challenging. So, negative 2x squared equals 20x plus 50. So I'm going to put it in standard form. So I'm going to move the 2x over because I want it to stay positive. So now I have 2x squared plus 20x plus 50 equals 0. Now, notice from the factor completely lesson that we learned in chapter 7, I can factor out a GCF before I start. I'm going to divide everything by 2. So now I get x squared plus 10x plus 25 equals 0. Now I have a simpler trinomial that I can factor here. The factors of 25, that will give me 10, which are going to be 5 and 5. So x plus 5, x plus 5. I still have my GCF out front. So now at this point, you're going to set everything equal to 0. So this piece, and this piece. So now 2 equals 0, that's nonsense. I can get rid of that. But the x plus 5s, and really I only need to do it once. And notice this is only going to hit the x-axis one time, and it's at negative 5. So this one has only one solution, even though it started out kind of complicated. So x equals negative 5 is the solution for this. Okay, here we go. They've done the check. They plugged in negative 5, and it did work. Now, helpful hint, when you see that it's a perfect square, since both factors are the same, just solve one of them. You don't have to show me x minus 3 equals 0, x minus 3 equals 0. Once you see that you get the same factor, just do it one time and then solve it once. Everybody understand what I'm saying? You don't have to do it 2 times. If you want to, you can, but you don't need to. Okay, here's another example, the same one that they just showed, the x minus 3. We're going to find the factors of 9 that give me negative 6, and those are negative 3 and negative 3. Set each equal to 0 and get x equals 3. So they showed you doing it 2 times, but again, just do it once. This one you have to put in standard form first. So for example, we have x squared plus 4x equals 5. Got to get it in standard form, make it equal 0. And now we're going to look for the 2 numbers that multiply to give negative 5, but who will add to give positive 4. And those 2 factors happen to be negative 1 and positive 5. X minus 1, x plus 5. And then you'll set them equal to 0. So x minus 1 equals 0, x plus 5 equals 0. Add 1, x equals 1 is the first solution, and x equals negative 5 is the second. Pretty good on those? All right, let's see what's coming up next. And here's their graph, just to confirm that it does hit it at 1 and -5. Here's another example. This one's a little more challenging because there was a number in front of x squared. And we practiced this on the weekend. So we have 30x equals -9x squared minus 25. Standard form. I need to move this over. Move the 25. Now I have a trinomial that I can factor. And this actually is this is a perfect square trinomial. So I can square root them. So this becomes 3x plus 5 and 3x plus 5. You could still do it the long way if you want. Multiply 9 and 25. Find the factors of that large number that give you 30. So notice again, I only have one thing here. So I'm going to just solve one of them. Now I'm going to get a fraction here. So 3x plus 5 equals 0. Minus the 5. Divide by 3. And my solution is x equals -5/3. So whenever you have a leading coefficient that's not a 1, you're going to get a fraction answer. And you're going to have fractions on the test. So be ready for them.
Will we have to graph it on the test?
I'm not sure. I'll give you more details about that. Probably tomorrow or Wednesday. Actually, the test is multiple choice. So you're just going to have to look for the graph that matches your graph. Okay, so here was the graph. And notice it had 1, 0 at -5/3. All right, so here again, we're going to, this one's not a perfect square trinomial, so we got to work for this one. There isn't one. So 3x squared minus 4x plus 1. I'm going to multiply the beginning and the end. I'm looking for two numbers that will multiply to give me 3, but who will add to give me -4. And those two solutions, or two numbers, are going to be okay, so those two numbers are -1 and -3, because this is a +3 here. So I'm going to do 3x minus 1 and 3x minus 3. This one can't be simplified. This one I can divide them both by 3. And I have my two binomials, and now I set them equal to 0. Again, you're going to get a fraction answer. So this one's +1, but this one gives me a fraction. So my two solutions are 1/3 and +1. And here is their check. They're plugging in both solutions. Make sure that it does work out, and it did. Here is a word problem. Again, these word problems, or this lesson, is good standardized test questions, good SAT questions. There's a whole section on the SAT called the Heart of Algebra, and all of this is in it. So here it says, the application is the height in feet of a diver above the water can be modeled by this quadratic function, where t is the time in seconds after the diver jumps off the platform. It wants us to find the time it takes for the diver to reach the water. So when it reaches the water, that's going to be our 0. So we have to factor this. So we would find the factors. This is actually, we could divide it first by a GCF of -8. And then we have a nice simpler trinomial to factor. Yes?
How's the GCF a -8?
Because
Positive.
remember, we want to keep our t squared positive. So that's why we're going to pull out a negative GCF.
Oh.
So always try to make your squared term positive. It makes it easier to factor. Okay, then you set each equal to 0. We don't want a negative time, so this answer here, when they solved it, is negative half. We're going to throw that out because we don't want negative time, so it would take him 1 second to splash into the water. So when you're doing the word problems for this, make sure you interpret what they are. You have to interpret the meanings. Same problem, but it's another diver, and they're giving us a different equation for this diver. So once they pulled out a GCF, then you factor what remains. Again, we're going to, okay, and again, you're going to set it equal to 0. This was a throw out the negative answer. This time it happens to be the whole number, and then they get 1.5 seconds for this diver to reach the water. And here is just a quick review problems. So basically in tonight's homework, you're going to factor. After you factor your trinomials, you'll set them equal to 0, and that would be the solution or solving the quadratic equation or the quadratic functions by factoring. So your homework tonight is practice B. Tomorrow we'll go, practice A. Thank you, Carlos. Practice A. Tomorrow it'll be practice B. And then on Wednesday, we will begin reviewing. Your test is on Thursday. Remember, it is a multiple choice test. There are only 15 questions. There is no partial credit. So make sure you have looked over your homeworks. Make sure you've written down the correct answers so you understand what you're looking for. And that is 8-6.